So what if the events are not mutually exclusive? So what if they could occur at the same time? So our example here is, what is the probability of selecting a diamond or a face card? So let me write up here, events that are not mutually exclusive. They could occur at the same time. So they're not mutually exclusive. So you can say, well, what's the odds of getting a diamond? Well, we know the probability of getting a diamond. So we're figuring the probability of getting a diamond or a face card. So you can figure out the probability of a diamond, getting a diamond. That's a diamond. There are 13 diamonds in the deck out of 52. And then you can figure out the probability of getting a face card. We know how many face cards are in the deck. There's 3 for each suit, 4 suits, so there's 12 out of 52. But the problem is you've double counted, because some of those face cards were counted when you did the diamonds. Okay, so you have to subtract the probability of a diamond and at the same time it's a face card. So there were cards in the deck that were both a diamond and a face card, like the King of Diamonds, Queen of Diamonds, Jack of Diamonds. So there were 3 of those. Sometimes they'll write like King of Diamonds, Queen of Diamonds, only they can make diamonds, and Jack of Diamonds. Okay, so there were 3. I really can't make good diamonds. Okay, so we have to subtract those because we double counted them. We counted them in the diamond pile and in the face card pile. So we got to subtract 3 of those. All right, so that's how we do it. So let's see, what do we get here? 25 minus 3 is 22 out of 52, or 11 out of 26. Okay, so here's the formula. So when the events are not mutually exclusive, you're finding the probability of A or B, and they're not mutually exclusive. Then you find the probability of A plus the probability of B, but then you have to subtract the probability of when they both occur, A and B. Okay? All right. So here comes an example. It is equally probable that a pointer will land on any of the 8 regions. If the pointer lies on the border, spin again. Find the probability that the pointer will land on an even number or a number greater than 5. Okay, I don't have the spinner here, so I got to stop and get. Okay, there's my spinner. May have shifted a little bit there. Okay, so we've got this spinner. There's 8 regions. You have just to get a chance getting any of the regions. If it lies on the border, you got to spin again. So we want the probability that the pointer will land on an even. So even number or a number greater than 5. Okay, so what's the probability of getting an even number? Then we're going to have to figure out what's the probability of getting a number greater than 5. And then we're going to have to subtract the probability of getting both an even number that's an even number that's greater than 5. Okay, so here we go. It's probably harder to write all that out and actually do the problem. So what's the probability of getting an even number? Well, you've got a 2, a 4, a 6, and an 8. So 4 out of 8 are even. What's the probability of getting a number greater than 5? The 6, the 7, and the 8. So those 3. 3 out of 8. There are 8 choices, right? Now we have to subtract an even number that's greater than 5. So that's going to be both the 6 and the 8. So 2 out of 8. So 7 minus 2. The probability is 5 out of 8 of getting an even number or a number greater than 5. That's the probability. Okay. Stop. Stop.